All right, so let's first talk about indirect measures. Now, one way to think of it is just, it means we can't take a direct measurement. We're going to use instead similar figures to find missing measures. So here's a scenario that's pretty well known when it comes to this kind of stuff. Let's assume this tree is just too tall for us to just measure with a tape measure. We can't measure it directly. But what we can do is we can use similar figures to find its height. If you think of this scenario where this yellow line represents the sun. The sun is over here somewhere. It's hitting the peak of the tree, and it's going straight down. And so it's casting a shadow, this green line right here, from the base of the tree all the way to the tip of the green line right here. Now, because it's a specific time of day and this little girl is standing right here, same kind of thing with the sun. The sun's hitting the top of her head, and so her shadow is cast from her feet to the tip here. And so even though they're overlaid on top of each other, we can see that there's actually two similar triangles here. Here's the one that represents the girl's situation, the height of the girl, the line that represents the sun's rays, and then this bottom line which represents the shadow of the little girl's shadow. And because the sun's in the direct alignment with both of them at the same time, we get a similar triangle where this side is the height of the tree, here's its shadow, and that same line. And in fact, we can show that even though they're different sizes, they are similar because they're the same shape. If I match up the corners, let me bring this to the front here. Notice how these top two corners match up exactly, the same angle. Down here, these two corners match up exactly. And over here, these two right-hand corners match up exactly. So because they have the same angles, they must be similar figures. Okay, so it's that type of idea that is how we're going to use similar figures to find missing measures. Now, here's how we do it. Let's assume we've already been told that these two triangles are similar. Well, what we want to do is turn the corresponding sides into ratios. So here, I'm missing one angle here, or not an angle, I'm sorry, a measurement of a side. Here I've got 15 inches, and in the old figure I've got 5 and 6 inches. So what we want to do is we want to match those up. And so for our missing one, let's call it x. So what I would do here is say, well, x corresponds with 5 inches. So I'll turn that into a ratio, x over 5. Now, because I've already been told that these triangles are similar, what I then can assume is that this ratio, 15 over 6, is also a similar ratio. So now what I can do is I can just solve this equation, and specifically with proportion equations like this, we cross multiply. So 5 times 15 is 75, and x times 6 is 6x. Divide both sides by 6. These cancel, and so x, the missing inches right here, is going to be, let's see, 1, carry the 1, 2, 12.5. Okay, and so that's how we found this measurement. We didn't take a direct measurement by measuring it. We went about it indirectly by using the measurements from the other similar triangle and used proportions to find that number of inches.